Hey, good morning, 8th grade algebra class. Sorry that I can't make it to another class today, but today I'm going to try to give you a quick little video about how to solve quadratic equations through graphing. Yesterday, you spent some time learning how to graph a quadratic equation on a coordinate plane. I'm hoping that went okay. I know that can be sort of tricky, but today we're going to take a little bit of the pressure off of the process of actually creating a graph and focusing more on how to interpret the results of the graph that you've created. And so this is chapter 9, lesson 5, solving quadratic equations by graphing. The first thing you need to know, there's really 3 steps that I'm going to try to emphasize in this video. The first step is you have to learn how to write a quadratic equation in something called standard form. So we're going to try to learn how to write it in standard form. So I have an example right here. It says x squared minus 4 equals 5. I'm going to change that, sorry to confuse you. It should say x squared minus 4x equals 5. It's close to being in standard form, but in standard form, you're going to have all of your variables and all of your coefficients on one side of the equation sign, and you're going to have 0 on the other. So when I look at this quadratic equation, what I need to do is move that positive 5 to the left side of the equation. So to do that, I'm just going to subtract 5 from each side of the equation. And when I rewrite that, I get x squared minus 4x minus 5 equals 0. This would be considered in standard form. To be in standard form, you always want the x squared term first. You want the single term of x second, and you want just the coefficient or the standard plain number third. All right, so we have x squared minus 4x minus 5 equals 0. You've taken your quadratic equation and put it in standard form. Step 2 is to graph the equation. So here's that same equation that I've been working with, x squared minus 4x minus 5 equals 0. All right, so yesterday you would have taken this information, you would have found the vertex, you would have found some points, you would have mirrored them on the other side of the line of symmetry and drawn a line, or drawn the parabola. Today, we're going to take a quick little shortcut, and we're going to try using the program called Desmos. And so if you have Desmos, you can punch that in on your computer, and I'm going to pull it up here as well. And this program does some pretty amazing things because it can graph your quadratic equations without much effort. So here we go. I'm going to type in that equation, x squared minus 4x minus 5 equals 0. All right, so I wrote it in standard form. Now this is doing something kind of interesting because if you see this, it doesn't quite look like a parabola anymore. And so I'm kind of trying to figure out that if I take out the equals 0, and if I just do it like x squared minus 4x minus 5, just forget doing the equals 0 piece, just write it like that. What you'll see is a nice looking parabola. You see that there is a vertex down here. Looks like the vertex is at 2, negative 9. And you see these 2 points right here. And these become the really most important parts of the quadratic equation, or the graph of the quadratic equation. We call these the x-intercepts. It's where the parabola hits the x-axis. Okay, so now that we've identified that, these 2 numbers, negative 1, 0, and 5, 0, those 2 values on the x-axis are your solutions for your quadratic equation. So we're going to look for the 2 spots that the parabola hits the x-axis. Remember, negative 1, positive 5. So when I come back here, we graph the equation. I'm just going to put the notes here. Use Desmos. I don't want the process of creating a graph to be the problem today. Step 3 is the solutions for the quadratic equation are the x-intercepts. We sometimes call these the roots of the quadratic equation. So again, if we look back at Desmos, we saw that there's a point at negative 1 and at positive 5. And so the roots are negative 1 and positive 5. And those become my 2 solutions. That's the answer that we're looking for. When we put negative 1 or positive 5 into our original equation, it should spit out a value of 0. So today, you're going to be trying some different problems where you're going to take a quadratic equation. Sometimes you're going to have to rewrite it in standard form, like part 1, just rearrange terms so it equals 0. And then sometimes you're going to take an equation and punch it into Desmos and look for the solutions or the roots of the quadratic equation and find the number of answers and what those answers specifically are. I should make a quick note that it is possible that when you graph a parabola, I'm going to sketch these out here a second for you, you're likely to get 2 answers. Here's a quick little graph, right? There's a spot that would hit at the x-axis there and a spot that would hit the x-axis there. It is, however, possible that your parabola comes and just touches that x-axis in just one spot. So there might only be one answer depending on how you've drawn it. And it could be possible that you have no solutions. The parabola never touches the x-axis. Then you'd have no solutions and that would be your answer. I think that today all of your graphs will probably hit the x-axis at least once, but just trying to acknowledge that those are possibilities in the future. Okay, I'll leave a homework assignment for you to try some of this out, and good luck. Help each other out. Thanks.